All right, let's take a look at graphing inequalities, okay? So the whole point of graphing an inequality is figuring out a few things. You first need to figure out if your line is a solution, okay? If your line's a solution, then you're going to draw a solid line. If it's not a solution, then it's a dotted line, okay? Then you also need to know where to shade, okay? And it just depends sometimes. So you can easily graph these with a graphing calculator and see how to do it that way. I'm not really talking about doing it that way. I'll be talking about doing it by hand. So you know if it's solid is if it's going to be equal to, okay? So if it's less than or equal to or greater than or equal to, it's going to be a solid line. If it's not equal to, so just less than or greater than, it's going to be a dotted line. And where to shade, a great way to do is to check that with a point. Generally, if it's y is greater than, you shade above, and y is less than, you shade below. The problem is when we get to problems like this, okay? And we can solve it for y, or there's another way we can do it as well, okay? So let's start off. So we first graph our line, so plus 2 means our y-intercept of positive 2. Then we have a slope of negative 3 over 2. So I go down 3, to the right 2, down 3, to the right 2, or up 3, and to the left 2, okay? And then it's got the line, so it's going to be a solid. It's part of the answer. Whoops, wasn't a very good drawn line, okay? Then I've got to figure out how to shade. This says y is greater than, so I'm assuming I'm shading this direction. But I want to use a test point to double check. So I like to use the test point 0, 0. Okay, so I put in 0 for y, 0 for x, and then we solve. So negative 3 halves times 0 is 0. 0 plus 2 is 2. Is 0 greater than or equal to 2? No, it is not. So that 0, 0 wasn't on the side where the answer is, which means yes, we shaded the other side. Now again, if you're just using a graphing calculator, you just go to your, entry edit bar, and you would just, hit delete on the equal sign, and then put in the correct format that you needed to have. Okay, so let's take a look at number 2 now. So now this one, notice there's no y, so it'd be like an equation x equals some number. Whenever we just have x equals that number, we go on the x-axis and we draw that line there, okay? So x equals 1, we would have drawn that line. Now we look to see, should it have been dotted? Nope, it's got a sign. So then it says x is greater. Well, bigger x's, we shade to the right. Okay, because it's a straight line, or a vertical line like that, we don't really need to worry about making it work better. Okay. All right, number 3. Y-intercept of negative 3, slope of 2, which means up 2 to the right 1. Okay, there's no equal to, so this time it's going to be a dotted line, so I just draw a dotted line here. It says y is less than, so most likely I'm shading below, but I can use a test point 0, 0 to double check. I get 0 is less than 0 minus 3. Is 0 less than negative 3? It is not, so I was correct in doing the opposite side as the 0, 0, right? So shading the right side or below. So in the slope-intercept form, that works out just fine. Okay, y-intercept of negative 5, slope of negative 1 to the positive 2, or positive 1, negative 2. So I get that. There's no equal to, so again, another dotted line, because my line is not a solution. Then where are all the rest of my solutions? Well, it says y is greater, so I'm assuming they're going to be above, like that. I can test this point 0, 0, and because that's part of my solution, that I'm thinking is my solution, it should work. Negative 1/2 times 0 is 0. 0 minus 5 is negative 5. and 0 is greater than negative 5. So I was definitely going in the right direction. Okay, number 5. Positive 4 for my y-intercept. Slope of negative 2, so down 2 to the right 1. Or up 2 to the left 1. There's no equal to, so it's a dotted line. Okay, then its y is greater, so I'm probably shading this direction. 0, 0 wouldn't be a solution, so if I plug in 0, 0, it should be wrong. That would be 0 plus 4, would be 4. Is 0 greater than 4? Nope. So we were correct. Okay, number 6, negative 5. Slope of negative 10 over 3. So I go down 10 to the right 3, or up 10 to the left 3. So right there. So equal to, so it's a solid line. Y is less than, so I'm probably shading down here. I check with that test point, 0, 0. In this case, it shouldn't work. So I get 0 minus 5 is negative 5. And 0 is not less than or equal to negative 5. So we were correct. Okay, now we can't really use that when we're dealing with these in more of the standard form. So now, the easiest way that I can think of to tell you how to graph these standard ones, yes, we could take it. Let's look at number 8. I could subtract x from both sides, get 2y is less than negative 8 minus x, then divide by 2 on everything, and end up with y is less than negative 4 minus 1/2 x, or y is less than negative 1/2 x minus 4, and then graph that way. Okay, that is an option that I could do, and that's not a bad option. Okay, the problem with that is that's a lot of work. Then you still have to graph it, when I think there's probably an easier way. Okay, and the way that I would think about this is by taking and thinking, okay, we want to figure out where on the x and where on the y, and I did those backwards, x and y axis this would go. Where would it cross? What are the x and y intercepts? Okay, and the easiest way to do that is to think, well, what if I got rid of the y here? If I had no y, what would my x be? Well, x is less than 0, so x would be right here. Okay, then I go, well, what if I got rid of the x and just had the y? I'd have y is less than 0, so I'd graph it right there. And this is like the one situation where this really doesn't work too well. Let's do number 8 first. So let's say we got rid of the x. I'd have 2y is less than negative 8. Divide by 2. Y is less than negative 4. So negative 4 for y would be right there. For the x, if I got rid of the y, it would be x is less than negative 8. So x would be out here at negative 8. Okay. Then I connect the two dots, realizing that there's no equal to. So I just draw a dotted line going through those points. Okay, there's my line. Then for shading, okay, I can pick a test point, but there's another way you can think about it, okay? And think about it this way. X is less than negative 8. Which direction on the x-axis would make it negative? Would make it smaller? Would be to the left. For the y, it says y is less than negative 4. To make it smaller, it would have to go down. Notice then that that's basically telling me I would shade in this direction. Okay. So if I can double check that by plugging in this test point 0, 0, 0 for x, 0 for y, 0, 2 times 0 is 0, 0 plus 0 is 0. Is 0 less than negative 8? It is not, so that wouldn't be an answer, so I was correct shading the side I shaded. Okay, so now in this case, number 7, okay, really this one you do need to kind of know which way it's going. So if I subtract an x, I'd get y is less than negative x. So a slope of down 1 to the right 1 means, and there's no equal to, so it's a dotted line going this direction. Okay, but I can still use the idea of shading. X was less than 0, so I'd shade that way. Y was less than 0, shade that way. There's my shading. Again, I can't use the point 0, 0 because it's on the line and I already know the line isn't a possibility. But I could do 1, 1. 1 for x, plus 1 for y is 2. Is 2 less than 0? It is not. Okay, so that's probably an easy way you can deal with these ones. So let's take a look at 10. Now this one has no x. So if that's the case, think of it this. Y is less than negative 1. Well, y is negative 1 right here. If I press down, if I go down, that would make it less than negative 1. So if I have a dotted line here, because it's not equal to, I know that I'm shading everywhere below, so I'm shading below that way. Okay, number 9. So if I had no x, or no y, I would just have x is less than or equal to negative 25. So negative 25 would be clear out there. Okay? And then if I had no x, I'd have negative 5y is less than or equal to negative 25. Divide by negative 5. Remember, when we divide by a negative on inequalities, you change it to the opposite direction. So I'd end up with y is greater than or equal to 5. Okay, so y is going to be bigger, so I shade above. X I shade to the left, so there's an equal to, so I draw my line, and then I shade above. Again, if you didn't believe me, plug in 0 for x, got 0.00, 0 for y, and I would get 0 is less than or equal to negative 25, not true. Okay, if I wanted to try a point that would be true, try 6 for y. So x would be 0, y would be 6. I'd get negative 30 is less than or equal to negative 25, and that is true. Okay, last two. So if I get rid of y, I have x is less than or equal to negative 2. So negative 2 is less than, so I'm probably shading that way. Then if I just had y, y is less than or equal to negative 2. Well, negative y, because that negative's got to stay with it. So to get it not negative, I would make it positive, and the other side positive, and flip the inequality. So y is positive 2, and y is greater, so it's going above. So there's an equal to, so a solid line, and you can see which direction I'm going to shade. Okay, and the last one, 12. If I had no y, we'd end up with 2x is greater than or equal to 2, divide by 2, get x is greater than or equal to 1, greater than, so we're shading, going to the right. Then if I had rid of the x, it would be y is greater than or equal to 2, so positive 2 for y, y is greater, shade up. There's an equal to, so a solid line, and I can see which direction I would be shading. Okay, so there's the easiest ways to do them by hand. And again, if you have a calculator, you're able to write it like this if you turn it to that relation form. Again, if you've got the function notation when you open the graph, okay, you delete the equal sign, scroll down to number 6, relation, then type it in how you see it, and then you're able to transfer it to a graph. All right, that's all there is to it, guys.